You can copy this down. If you flip it over, we're going to have graph number 7, graph number 8, graph number 9, 10, 11, and 12. Number 7 is going to be a natural logarithm. Y equals ln of x. Draw your xy axis. And ln of x is the inverse of e to the x. E to the x went through 1, 0 and grew rapidly. The inverse, instead of going through 1, 0, is going to go through the inverse of 1, 0. The inverse of 1, 0 is 0, 1. And instead of growing rapidly, it's going to grow slowly. And this is symmetric, or beautiful, along the line y equals x. And we've graphed y equals x. We've graphed y equals e to the x. And a couple of times we've graphed y equals ln x on the same graph. This is gradual growth. Number 8, we're going to graph y equals log base 2 of x. I'll do my xy axis. It's going to also go through 0, 1. But what's nice about logarithms versus ln and e, it has another nice point. I'm sorry, I forgot to put 0, 1 here. As it grows, I know it's going to go through another nice point, and I get that other nice point from that 2. So if I go right, 1, 2, up 1, it's going to give me a nice coordinate. And bingo. Number 9, y equals log base 3 of x. Y-axis, x-axis. It still goes through 1, 0. It's going to creep up along the y-axis, go through 1, 0. But now because of that 3 as the base, I go right, 1, 2, 3, up 1. And it's going to go through 3, 1. The domain and range for these, if I go back to graph number 7, the domain is now going to be restricted. The smallest x value is almost 0, so it's going to be parentheses 0 to infinity. It goes to the right forever. The range, the smallest y value, is negative infinity. It comes from negative infinity and grows upwards with the y values to positive infinity. The same domain and range is going to be for this one. The domain is going to be from 0 to infinity. Then the range is going to be from negative infinity to infinity. The domain, 0 to infinity. The range, negative infinity to infinity. Graph 9, 10, and 11. I'm sorry, graph 10, 11, and 12. Graph number 10 is y equals log base 4 of x. It's going to go through 1, 0. It's going to creep up along the y-axis, hit that point and turn, and then it's going to go through 1, 2, 3, 4. Everybody get on the dance floor and go up 1. So it goes through 4, 1. The domain is going to be from 0 to infinity. The range is going to be from negative infinity to positive infinity. Number 11. Y equals log parentheses x plus 2 close parentheses minus 1. Now, if there's no number there, there's a hidden number. And that hidden number is 10. It's just the convenience that we don't put it there. If it just says the word log, it's actually log base 10. I'm going to put the 10 there now. You might want to also. I'm going to squeeze this graph over to the left a little bit. And I'm going to implement opposite same. So the graph will go left 2, down 1. So I'm going to go from 0, 0 and move it left 2, down 1. And that's going to be my new make-believe 0, 0. And now, log base 10 of x plus 2 minus 1. If this were my new 0, 0, I've shifted the whole picture left 2, down 1. It's going to creep up along this new asymptote, go through this coordinate, which is 1 away from the new 0, 0, and then go right from there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up 1. Goes off my graph. This coordinate is at -1, -2. This coordinate is at 8, -1. The domain is from -2 to infinity. Now notice, the asymptote went left 2. So x equals -2 is the asymptote, the vertical asymptote. The range is going to be from -infinity all the way down low, all the way up high. It does continue to go up, it just goes up really slow. So it's going to be -infinity to positive infinity. Number 12, we're going to graph y equals log x. It's going to go through 1, 0, creep up, go through that point, and then it goes over the hidden base of 10. So I'm going to go right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up 1. This coordinate is 1, 0. This coordinate is 10, 1. Domain, 0 to infinity. Range, -infinity to positive infinity.